So, I have received a question from Khan Parvez. Sir, could you upload video on YouTube differentiating angular velocity and angular frequency? So, there are two terms, angular velocity and angular frequency. So, wants to find the difference. Now, angular velocity, when you say, you have a particle going in a curved path or a circular path. So, this is the situation in which this angular velocity is a relevant word. So, if you have some origin and then there is some axis, some line, and you have a particle at some certain time it is here and this angle is theta and it is rotating, it is going. So, the particle reaches somewhere else and then you can ask that what happened to that theta. So, that theta is increased, that theta is changed by angle d theta, and if the time taken is dt, then you say that d theta dt is the angular velocity. So, this is when a particle is going on some path and then angle with this line which is fixed line is changing with time, and then you say that the particle is rotating and moving in rotational motion, and then you define this angular velocity term d theta dt. Angular frequency, frequency comes when there is something periodic, anything periodic like our AC, the power which is used in houses, it is AC power. So, current which is going in your tube light or in bulb, so it is an AC. So, how do you write the current? The current is some constant times sin omega t or cos omega t, like this. There is no rotation, nothing is rotating, no angle is changing, theta does not become theta plus d theta. It is only that you have a wire and then you have a current, and the magnitude of the current and direction of current is changing, and at any time t the current is given by this. So, frequency can be of any periodic motion, any kind of periodic phenomena, not necessarily motion, any kind of periodic phenomena you will have frequency. How many repetitions per unit time? How many repetitions per unit time? If you are blinking your eyes very regularly, you can ask what is the frequency. Or sound wave, the pressure of air changes, compression and then rarefaction, compression and then rarefaction. There is no rotation as such, there is no rotation, no angular velocity involved, but yes, per unit time these many times you have compression and you have rarefaction. So, any phenomena which is periodic, for that you can define frequency. So, frequency is number of repetitions, you can say, per unit time. So, depending on what is that phenomena, this will have different meanings, but essentially after how much time it repeats. So, that is the time period, and the opposite per unit time how many repetitions, that is called frequency, and it is represented by those kind of phenomena can be represented by this kind of function sin omega t, cos omega t, this kind of function, and this omega and this frequency they are related. This is 2 pi nu. The frequency is nu, number of repetitions per unit time, cycles per second or hertz. So, that is frequency, and then 2 pi times nu is omega, which appears in this equation. When you describe that quantity as a function of time through an equation which is repeating regularly after a certain time interval, you have this kind of equation, and this omega appears here, and therefore, it is an important quantity. This is known as angular frequency. So, that is the relation between angular frequency, and frequency is one by time period and so on, and here is angular velocity, where something is actually rotating and some angle is changed, and the rate of change of that angle is known as angular velocity. And if the particle is going on a circle, that is also a repetition. If the particle is going on a circle with uniform speed, then also you can talk of angular frequency, because you have frequency, you have repetition. So, you can calculate what is this angular frequency, and you also have angular velocity, and it may happen that the two have the same value, but the meanings are very, very different.